Hello, scholarly gamers, and welcome to Proof of Console, the show where we look at something from video games through a mathematical or scientific standpoint to see how plausible it really is. If you want my opinion, Mass Effect is probably the greatest hard sci-fi game there is. Every time I come into contact with it, I'm amazed by just how detailed the lore is. It's practically like reading out of a history book about humans' entrance into the galactic community. Well, a future history book, if that's a thing. So with all of these completely believable circumstances, does it mean that some of the things taking place in the game are actually possible or even probable? Like perhaps mankind's greatest dream, interstellar space travel. That's what we're about to explore on today's episode. According to Mass Effect's lore, the reason that people can travel from star to star in a reasonable amount of time, say a day or so, is due to giant mass relays that fling spaceships at ridiculous speeds toward their destination. And the only way that they work is because of the sci-fi favorite, Element Zero. Now, Element Zero is a bit of a misnomer, as it isn't actually a chemical element, humans just incorrectly assumed it was, but it has the unique capability of generating dark energy. When applied to drive cores, armor, toothbrushes, or even that dumb, stupid, slippery, six-wheeled monstrosity, they can increase or decrease their mass depending on if a positive or negative charge is run through them, thus the term Mass Effect. In the Mass Effect universe, Element Zero is extremely rare and dangerous to mine due to its radioactivity. The mineral only forms on planets or asteroids near stars that have gone supernova and have been reduced to pulsars or neutron stars. This may explain where the dark energy comes from and why we in the real world haven't found any yet. So to explain things as simply as possible, Mass Effect fields make space travel possible because when flinging things through space when their mass is 0 or even less than 0, time does not dilate like things with a regular amount of mass. In other words, time moves differently depending on how fast you're going, especially if you move near the speed of light. Alright, that may seem like a lot of technobabble, but fortunately almost every detail we have to solve this plausibility conundrum has actual basis in science fact. Let's dive right into it. First off, even though Element Zero isn't an element, there was a German chemist named Andreas von Antropoff who theorized there was an element lighter than hydrogen. Rather than have a proton at the center of the nucleus of an atom, a neutron could be found. As far as we know, the so-called neutronium doesn't exist, but it could be out there on planets other than Earth. Second is this idea of dark energy. It may sound like some sort of ancient evil power from a fantasy novel, but actually it's real. In fact, we can detect that dark energy, and it takes up about 68 to 74% of the mass in the universe, which is absolutely huge compared to everything else. Dark matter around 23%, and planets, stars, dust, and gas only take up about 4%. So what is it, and how do we know it's there? Well, we have no idea what it is or where it came from, but we do know that it is what's making the universe expand at an exponential rate. One possible explanation is that dark energy is actually a fifth fundamental force. Currently, we know that there are 4 fundamental forces. The strong force, which holds particles together on the atomic level like quarks inside protons and neutrons, and those particles together in the nucleus. The weak force, which causes unstable atoms to decay into more stable ones. The electromagnetic, which describes how waves interact with each other, radio waves, visible light, X-rays, and so on. And gravity, which pulls everything made of matter toward everything else, and gives that matter weight. So what does dark energy do? In the hypothetical, dark energy would be called quintessence, and it would either be like the weak force, or be more like gravity except working with mass instead of weight. And that little detail is what tells us that mass could potentially change under certain conditions. In fact, we've actually come close to accomplishing this incredible feat of changing an object's mass. In 2017, researchers at Washington State University performed an experiment in which they cooled rubidium atoms down to near absolute zero. At this temperature, really weird things start to happen, and indeed the atoms became a superfluid. In superfluids, atoms are in a liquid state but act like solids, in which they move all at the same exact directions in exactly the same time. When the experimenters fired lasers at the supercooled liquid, it gave the illusion that it had lost all its mass and went into the negative. What does an object with negative mass do? Unlike normal conditions where mass is affected by gravity and moves in accordance with it, negative mass causes objects to move by themselves backwards, with no propulsion whatsoever. This is where we can connect back to Mass Effect fields. If a ship were to lose all properties of mass, it would need no actual force pushing it forward and can travel faster than light, negating time's relative effects. This also removes any energy added to an object moving. Since you need energy to make anything move, and energy technically has mass, although minutely, thanks E equals mc squared, the faster you go, the more mass you'd accumulate. Not when you had less than 0 mass to start with, though. So could Mass Effect's idea of space travel really be possible? Believe it or not, if there were a substance that could generate dark energy, and if dark energy can actually change an object's mass, and we could harness this substance to work for us as needed, then yeah, we actually could create FTL travel. And with this technology in tow, we'd be romancing space velociraptors before you could say interspecies relationship. Thanks for watching, and if you have a question about a video game you want answered, leave it in the comments. Also in the comments, tell us, how likely do you think it is that we'd harness a technology like this? Is there a method from another game you think would be more plausible? If you haven't checked out the first episode of Proof of Console on the actual worth of a golden Jiggy from Banjo-Kazooie, here's a link to that. And until next time, I'll see you for the next fine installment of Proof of Console.